This series of videos continues the material on classes and objects. So this is the second part of the lectures on classes and objects. Make sure you've watched the first part first and have a good understanding of all of those topics, because we're going to build on them in the second series of lectures, talking about some more advanced topics related to classes and objects. We'll talk about overloading methods, the this keyword, the static keyword, aggregation, packages, and enumerated data types. So a brief review of what we talked about with class design. A class is a concept of an object. So you can think about a class as kind of a blueprint of that object, and then once you write the class, you can create as many objects of that class as you want to. So the class just defines the blueprint, doesn't actually create any objects. There are a couple of basic building blocks that you should put in all your classes. Private instance data variables. That defines the characteristics of an object. Constructors set up objects. Getters and setters allow public access to your private instance data variables. And a toString method provides a text representation of your objects. Those are your core building blocks, and then after you've gotten those written, you go ahead and add any private or public class-specific methods that make sense for that class. Again, the class is the blueprint, and once you have that blueprint, you can instantiate as many objects of that class as needed. To instantiate an object, you use the new operator and a call to the constructor, sending in any information that's required by the constructor as parameters. Then once you have that object, you can invoke any of the methods defined in the class on the instance of that object by using the name of the object, the dot operator, followed by the name of the method, and any actual parameters required by the method. So that's a very brief review of what was covered in the first set of lectures on classes and objects. If any of those things aren't quite clear, please return back to that first set of lectures, go over that material again before continuing on. So we're going to begin by talking about method overloading. Method overloading allows you to have multiple methods that have the same name, but a little bit different functionality. Now the methods have the same name, so they have to differ somehow, and they differ by one or more of these things. They differ by the number of parameters that they take, the type of those parameters, or the order of those parameters. So basically the names of the methods are the same, but something about the parameters are different. One method we use all the time that actually is overloaded is the printline method. So the system.out.println method, we think of it as a single method, and we can send in the string hello to be printed to the console, we can send in the number 35, or we can send in the number 42.5. But that method is actually overloaded. There's actually 3 different printline methods, actually more than that. There's one that takes in a string, one that takes in an int, and one that takes in a double. So this is a classic case of overloading, because the idea is that all 3 of these methods have the same name, because they're really doing the same thing. They're printing some value to the console. And from the user's perspective, we don't want the user to have to come up with different names for all these, to use different names for all these methods. It would be a real pain if we had to say system.out.println string, system.out.println int, system.out.println double. That would be really annoying, because we want to do the same thing, right? We just want to print something to the console. So by overloading, it lets us have three separate methods with the same name, just println. But these methods actually take in different pieces of information. So one takes in a string, one takes in an int, and one takes in a double. Now when a method is overloaded, the compiler can't obviously just use the name to figure out which method is being called, because the names are the same. So instead, the compiler looks at the parameters to figure out which version is called. Now the combination of a method's name and its parameter list is called the method's signature. Remember that the method header is the visibility, the return type, the name, and the parameters. But the signature is a subset of that. It's just the name and the parameters. The return type is not part of that signature. So that means that you can't have 2 different methods that differ only by their return type. That will not be allowed. So here's an example of 4 methods. The first method is called tryMe, and it takes in a parameter of type int. So these 2 pieces of information, the name and the parameter list, these are the method's signature. The name and the parameter list. That's the signature. So here's a second method, has the same name, and the same parameter list. Takes in just one parameter of type int. So this method's not going to be allowed. This method is going to give us a compiler error because we can't have two methods that have the same name and the same parameter list. That means the same name, the same signature. Note that it does not matter that this one's a double and this one's an int. That doesn't matter that they differ in the return type because the return type's not part of the signature. So again, this method is not going to be allowed by the compiler. This method will be allowed by the compiler because even though it has the same name as the first try me method, it has a different parameter list, meaning the signature is different. The first method took in just an integer. This method takes in an integer and a double. So this one's all good. This one will be allowed. Yep. Now this fourth one, again, will not be allowed because it has the same signature as the third one. The name is try me, and the parameter list is an int followed by a double, just like this is an int followed by a double. So note here that even though these formal parameters have different names, Java doesn't care about the names of our parameters. It just cares about the type. So if we have int double, that is the same as int double, even though the names are different. So this second and this fourth method are not going to be allowed, but this first and third method, these are appropriately overloaded methods in terms of their method headers. So when would you want to use method overloading? Well, again, you're going to want to use it when you have multiple methods that really do the same thing, but they take in different inputs to do that thing. So really you want someone who's using these methods to think about it like it's all one method, right? Just like we think about the print line method as being one method, but it's actually a whole bunch of methods that take in different kind of parameters. So if you have multiple methods that really are doing the same thing, but they just need different inputs, that's a good time to use method overloading. If you have different methods that are performing different tasks, do not overload them. Give them different names. So really only use method overloading if your methods are doing the same thing, but just taking in different inputs to do that. So let's take a look at an example of this by overloading the roll method in our die class. So in our die class we have our roll method, and let's say for example we wanted to have a second roll method that just rolled the die multiple times. You know, some games will say, you know, you get 3 rolls on this turn. Okay, so we want to have one method where you just roll the die once, and we want to have a second method where you roll the die multiple times. Well, that's really the same functionality, right? We're just rolling the die. Okay, so it's the same functionality, but it's going to take in a different number, different inputs to execute that task. To roll the die, we don't really need any inputs, but to roll the die multiple times, we need to know how many times we want to roll the die. So this is a good example of using overloading, again, because the two methods are going to really be doing the same thing, but they just need to take in different inputs to accomplish that task. So the methods are going to have the same name, but different parameter lists, so different signatures. Again, they both have the same name, roll, but this one takes in no parameters, and this one takes in one parameter of type int. So oftentimes in so let's just write this method. So I could start by writing a little loop in I equals 0, well I is less than num times I plus plus, and then I could, you know, say, okay, what I really want to do here is I want to generate a new random number and do it that many times, update the face value, and then return face value. Well, remember we've said in the past that any time you find yourself copying and pasting code, you should stop and think if there's a better way. There usually is a better way. So oftentimes in overloaded methods, you can invoke one version of the method from another to reduce that repeated code. We always want to reduce repeated code. It's very bad to have the same code in multiple places. So anytime you find yourself, again, copying and pasting, meaning you're putting the same code in more than one place, stop and think if there's a better way to do that. So for this example, instead of having this copied code, all I'm going to do is I'm going to invoke the other roll method. So this call here is invoking this method here. So all I'm saying is call that roll method this number of times. And then when I'm done, I just return whatever the current face value is. So it's not always possible to invoke one overloaded method from another. Sometimes they do need to have separate implementations, but oftentimes you can. And if you can do that, you should do that because it helps reduce that duplicated code. And we always want to reduce that duplicated code.